All right, welcome back into this, our first lecture on PLSQL. I'm juiced. I'm excited about PLSQL. This is what starts to separate the big boys from the little boys and those who wear the big boy pants, because we're now going to actually start coding inside the database using a language with incredible functionality. All of you are coders of some type, and as such understand the object-oriented programming mentality. Well, PLSQL is also object-oriented, but here our object of choice is going to be the table. We're going to be able to create variables like a field, like a row, and even like a table. So we're going to have some fun. We'll take a look at that. But first, a little caveat on the extent to which we delve into PLSQL. We could spend a long time on PLSQL, and it would be well beyond the scope of this course. This is an intro SQL course. We're going to touch on all components, but we are not going to delve into the deep end of the pond. By the way, second quarter of 2017, I will be putting out on Udemy a deep dive into PLSQL, so I hope you all check that out. Similarly, after that one, as long as I'm on my marketing step stool here, I'm going to be putting out a physical database design course for those of you interested in performance as well as DBA-like, super DBA-like activities. So please check both of those out in 2017. Okay, now before we dive into this particular lecture, please do our standard pause and download lecture18scripts.txt, fire up developer and log yourself in as my store, because we're going to run some cool stuff. Want to take a look as you follow along. Okay, we're going to start with this little procedure named update product suggested price. The basic premise here is we're going to look at all previous sales done on a particular product and update the suggested price of that product to be equal to the average of what we actually sold it to prior. Very straightforward and actually makes some sense in the real world. Let's start with the procedure declaration statement up here. Says create or replace procedure, update product suggested price, input parameter of my product ID of type products.productID %type. Looks like we're going to create a new procedure named update product suggested price if it doesn't already exist. Or alternatively, if it does exist, then we're going to replace the old definition with the one we're looking at. Next line says this procedure will accept a single input parameter, locally named myProductID, and it's going to be of data type productID field of products. In other words, whatever the products.productID field data type is, assign that to the local variable myProductID. You know, that's a good idea, because then if somebody goes out and changes the data type of a particular field, it does not invalidate your procedure. Instead, you, rather than use explicit variable data typing, you're using referenced variable data typing. In addition, please note that this particular parameter in our example is an in parm, but it could have also been an out parm or even an in out parm. And of course, our procedure declaration ends with the keyword as. Interestingly enough, Oracle also accepts an is keyword there in lieu of the as. Not really sure why, but it works. All right, let's move on to the next paragraph of code where we declare some simple variables. Check out how we declared, instantiated, and set the value of the cumulative value variable all in one line of syntax. Very cool. And we did the same thing with row comp. Next, let's check out the not used variable. Look like we're declaring it as a % row type. In other words, The not used variable will assume all the column names and data type properties of a row in the products table. Just something to remember though about the percent row type declaration. It does get it in the column names and the data types, but it does not move the constraints. As such, percent row type does not enforce things like not null, referential integrity, or defaults. Something that I wish they did, but it is what it is. P.S. This variable is aptly named. It really isn't used at all in this procedure. I just have it here so I had an opportunity to tell you about the percent row type declaration. Moving on, our comment tells us that we're going to define a cursor. Cool, I like cursors. Cursors are used to retrieve rows from a select statement embedded in a procedure function or trigger. Here are cursors named getPreviousSales and is defined as select row num and sales price from the order line items table where the product ID equals that my product ID passed in through the procedure call. Very standard stuff. You guys all know procedures and how they pass parameters. Next, we see the keyword begin paired with that final end procedure name down there at the bottom. These lines simply act to delineate the actual executable block of our procedure. The next paragraph of code opens a cursor row instance. In our particular case, we've named it this previous sale. This previous sale is going to loop that row instance through all the rows in our cursor defined above as get previous sales. Pretty straightforward stuff for coders. We're going to accumulate the value of sales price in the variable named cumulative value and assign the row count variable based on the row num cursor instance. Easy peasy once you see the syntax. By the way, Oracle will automatically open and close the cursor under this for loop syntax. If you use a while or a simple loop, then you need to explicitly open and close that cursor yourself. All right, the next paragraph's pretty easy. If row count is greater than 0, then update the products, setting the suggested price to the average of the previous sales where the product ID is equal to my passed in product ID parameter. All right, something to think about, guys. What happens if row count equals 0? And that is, our cursor found no rows, or that product ID has never been sold. Think about it. Correct. Absolutely nothing happens because that if then else doesn't fire. Yeah, PLL also has a while loop, but the normal case statement has to be realized via their rather archaic if else syntax. Sorry, gang. They gave us a case in the select statement, but they didn't give us a case in PL/SQL. Why, I'm not really sure, but it is there if you just jump through the if else syntax. It works, but it's rather clumsy if you ask me. Finally, at the bottom of this procedure, we see our exception handler. With an exception handler, you can trap specific errors or go with this more generalized solution. Your call, really, but I generally don't attempt to trap specific errors, and most coders don't either. If an error actually occurs, it usually means something pretty big has messed up, and I want the users to let my DBA or the database designer to know right away. Better to let them know than customer support getting bombed. Okay, let's go ahead and cut and paste the whole procedure now into developer and execute it so it's compiled and we can test it. First thing to do is always a describe. Cute, hey? Just like we did with the tables, now we can describe procedures or functions. Next, let's run this little query to see what we're dealing with in the order line items table with respect to products and their sales. Oh yeah, I remember now. It looks to me like if we ran our procedure on product ID 1, that we'd change the suggested price to $8.99. Similarly, if we ran it on product ID 5, we'd change that suggested price to $18.05. Let's see what happens when we run those procedures, as well as this one where we pass an invalid product ID. Again, you're all coders. You know that you always test with a potential error situation. Let's go ahead and run our query again and see if we can verify our procedure was working. Gosh, we must have been pretty clever because those results are exactly what we'd expected. Cool beans. All right. That was exciting for me. I mean, I'm sure you feel the same way. There's nothing like, as a coder, to learn a new syntax and start learning a new language. And this one is one that's pretty darn robust, pretty darn exciting. Let's review what we learned. We started with a simple declare procedure statement. If you'll recall, it's declare or replace procedure name, comma separated list of in, out, or in, out parameters as. You can also replace that as with an is. Oracle gave us a break for those who forget. Should be fun. We next looked at how to declare variables, variable name, and then either a specific data type, percent type, which points to a field within a table, or a percent row type, which points to an entire row within a table. Please remember on that percent row type, you don't get any of the constraints associated with the true table row definitions. So those not nulls, defaults, RIs, things like that do not come along. Interestingly enough, you can also in PLSQL define a table type and instantiate that, but that's a little beyond our scope for this particular class. So if you catch me in my next one, we'll get into that in great detail. We then learned how to define a cursor, really easy syntax. Cursor name is, and then the select statement, easy peasy. We then looked at delineating the executable block with a begin and an end procedure name. Everything inside is executed as part of the procedure, including and considering the exception clause. So that is considered as part of the executable block. Speaking of the exception block, most people just write exception others and then pass the user off to the DBA or the database designer because it normally infers something desperately wrong is occurring. A table space has run out of space, or we've got a concurrency issue, or something's going on, because normally these procedures are tested and don't fail under production situations. So if when you do throw an exception, normally you want to notify somebody up the food chain to get it fixed real quick. So consider that. All right, that's a wrap on this particular lecture. In the next lecture, we're going to take a look at calling functions. And in particular, we're going to write a function and call it from within this procedure we had just written. Should be good fun. All right, in the interim, you go out there and you have yourself some fun. But remember, learn something every day.